All right, we're going to do 4 different segments here, trying to help you guys out doing first binary formula, then ternary formulas, binary naming, and then finally ternary naming. We're going to do 3 of each. As I go through it, you can skip through the video because I'll cross off what I just covered. So whatever's below the line that is crossed off is what we're going over at that time. You'd need your periodic table and your polyatomic ion list to do this. So here we go. We're doing binary formulas right now. So we're working on this right now. Binary formulas, we're going to do zinc and fluorine. Now, zinc and fluorine, all you do is you have to find the oxidation number. So we have zinc, and we find out the zinc's in actually the transition metals, but when we look on our periodic table, we know zinc is a +1 charge because it gives 1 electron away. We find fluorine is in group 17. It has 7 valence electrons. It's going to take 1 for its oxidation number. We do a crisscross. We do our crisscross method. We get zinc 1, F1. We drop any 1s, and we reduce. There's nothing to reduce. Therefore, our compound is zinc, ZnF. There should be a space in between. Next one we'll do will be barium and carbon. Okay, with barium and carbon, we find out barium's in group 2. It'll be a +2 charge because it gives away 2. Carbon is in group 14. It's going to take 4 electrons. We do our crisscross method and we get barium 4, carbon 2. We drop any 1s. There are no 1s. But then we can reduce. Both these numbers are divisible by 2. 2 goes into 4 twice. 2 goes into 2 one time. But then again, remember, we drop 1s. So there we go. Ba2, kind of looks like a Z. Ba2, C. Then we have lead 2 chloride. Okay, now Roman numerals by lead, so we do Pb, and it's by lead because lead is in a transition metal, and when we look at our periodic table, we do not see a charge for it. This tells us that it is lead version +2, and chlorine is in group 17, it will take 1. We do our crisscross, Pb1, Cl2. Drop 1s, reduce. We're good. PbCl2. All right. Now we're going to go ahead and move on to ternary formulas. That's what we're working on now. And the first ternary formula we're going to do is calcium hydroxide. So, calcium, that's a regular old element, Ca +2. Hydroxide is not an element, so it must be a polyatomic. When we turn over our sheet, we find out hydroxide is OH, and it's a -1. Now, when we do these, remember, we can't mess with anything in there, otherwise it won't be that anymore. So we have Ca1 from there. Then we have parentheses OH, parentheses 2. We drop any 1s, good. We can't reduce, this is what we're left with. We do need those parentheses. Next we'll do copper 2 sulfate. Okay. Copper 2 tells you it's Cu, and again that's a +2 because of that Roman numeral that's in the variable oxidation area. And sulfate is SO4 and it's a 2-. Remember, we have to package these, and we do our crisscross. We get Cu2, then we get the parentheses SO4 2 down here. We drop any 1s, we can't. We reduce. Both of these are divisible by 2, so technically we would do this, but again, 1s aren't needed. And because there's nothing outside of those parentheses, we do not need the parentheses either. So again, there's not supposed to be a space. Cu, SO4. Okay? Final one, we have silver acetate. Silver is in the variable region, but when we look at it, it has a for sure charge. It is +1. And acetate is C2H3O2, and that is a -1 charge. Remember package? And we get Ag1, C2H3O2, 1. We drop ones. There's nothing to reduce. There's no number out here, therefore we do not need those parentheses. There you go. Now we're going to do the naming parts. This is binary naming. And we are going to name this thing right here Al-I-3. Step 1, we name the cation. That is aluminum. Step 2, if that thing has a variable oxidation number, we state it. It doesn't. Aluminum's always +3. Step 3, name the base of the anion and add IDE. This is iodine, therefore we would put iodide. Then we have MnO2. Step 1, we need to write down the cation. This is manganese. Step 2 doesn't have a variable oxidation number. It actually does. It's in the gray area, it's in the transition metal area, and it doesn't have a for sure charge. Don't do the reverse crisscross. Over here we have 2 oxygens. Over here we have 1 manganese. 2 oxygens, each oxygen is -2. Therefore, our total charge over here is -4. Remember, we got to get to an equal or no charge, which means we must be a +4 over here. If it is a +4, and there's only one of them, this must be manganese 4, 1B. Say the base of oxygen and add IDE, oxide. And finally, we have K2S. Name the cation. This is potassium. Variable oxidation number? Nope, it's always +1. Base of sulfur, add IDE. There you go, that one was real easy. Alright, that brings us to the last thing. We are doing ternary naming, which is actually probably even easier than binary naming. We're about the same. And the first one we're going to do is Ni3PO4. Step 1, name the cation. This is nickel. This one's kind of a tough one to start with. Does it have a variable oxidation number? Yes, it does. We've got to find it out. So we draw our line here. PO4 is a polyatomic anion. And when we use our list of anions, phosphate is a -3 charge. Over here we have 3 nickels. Okay? 1 phosphate, 3 nickels. Okay? And over here that means we have a -3 charge. To get to 0, this must be a +3. Well, there's 3 of them, so that means each one of them is +1. This is nickel 1. Step 3, if it is not polyatomic, you just say the base and add IDE. This one is polyatomic. If it is polyatomic, you just say its name. It's called phosphate. Next one, we have Ca parentheses, ClO3, parentheses 2. Step 1, write down the cation, this is calcium. Step 2, is it a variable? No, it isn't, so we don't need a Roman numeral. Step 3, if it is monatomic or not polyatomic, you just write the base and add IDE. This is polyatomic. Because it's polyatomic, we just state what it is, and this is chlorate. Now, some people say, wait a minute, chlorate's just ClO3. Well, it says just COL3. It is 2 of them. So if we would see this, we would see it like this. So chlorate obviously is a -1 charge each. Okay? Anyway, that's your actual wording for it. And the final one, NH4Cl. Step 1, name the cation. The cation is a polyatomic. That whole thing's a polyatomic. It is ammonium. Does it have a variable oxidation number? No, none of these have a variable oxidation number. So we go on to the second one. If it's monatomic, we take the base root and add IDE. The base of chlorine is chlor, and it is chloride. There you go. That's it. I hope this helped. If you still have questions with this, it is kind of overwhelming at times. Come in before, after school, and I can help you out.